So hey guys, welcome back to my YouTube channel hansda Education. So in today's video I am going to discuss about isomerism in organic chemistry. So let's start that. So here it is the isomerism. So what is basically isomer? Okay, so the compound having same molecular formula, same molecular weight, same degree of unsaturation, same vapor density, but at least one of the physical or chemical property different. That kind of compounds are known as the isomers. Okay, the compound should contain same molecular formula. When the molecular formula is same, then obviously molecular weight will be same, and the degree of unsaturation, that is du, will also be same. Similarly, the vapor pressure, I mean the vapor density will also be same. Okay, but at least one of the physical or chemical property must be different. Okay, so here it is the categorization of the isomerism. So the isomers are of two types basically. So one is the structural or constitutional isomerism, and another one is stereoisomerism. Okay, in case of structural isomerism, the IUPAC nomenclature is different. When the IUPAC nomenclature is same, then that will be your stereoisomerism. Okay, so stereoisomerism is also known as pseudoisomers, or it is not the true isomers. Okay, so the structural isomer or constitutional isomers are of 6 types. These are ring chain isomerism, tautomerism, functional group isomerism, metamerism or chain isomerism, and positional isomerism. Okay, and this is the priority order. First it comes ring chain isomerism, then tautomerism, then functional group isomerism, then metamerism, then chain isomerism, then position isomerism. If a certain compound shows two type of isomerism, then it will be decided by this priority order. Okay, so let's say one compound is showing both ring chain isomerism and tautomerism, then priority goes to the ring chain isomerism. Okay, so similarly stereoisomerism, in case of stereoisomerism the IUPAC nomenclature remains same. It is known as the pseudo isomer, or it is not a correct isomer. Okay, or true isomer. So it is basically divided into two types. These are the configurational isomerism or conformational isomerism. Again, this configurational isomerism is divided into two parts. These are geometrical isomerism and optical isomerism. So in order to show chain isomerism and position isomerism, the organic compound must contain minimum number of carbon, and here it is the table for minimum number of carbon required for showing either chain isomerism, or here it is the position isomerism. Okay, here it is the different organic compounds. These are alkane, alkene, alkyne, aldehyde, ketone, alcohol and other compound, and it is the minimum number of carbon atom required for showing chain isomerism. It is the minimum number of carbon atoms required for showing position isomerism. Okay, so for alkane, the minimum number of carbon atom required for showing chain isomerism is 4, and minimum number of carbon atoms required for showing positional isomerism is 6. So alkene it is 4 and 4, for alkyne it is 5 and 4, for aldehyde it is 4 and 5, for ketone it is 5 and 5, for alcohol it is 4 and 3. For the other compounds, the minimum number of carbon atom required for chain isomerism is 4, and for the position isomerism it can be 2. Okay, so this is the minimum number of carbon atoms required. Okay, so here it is the summary of different structural isomerism. These are chain isomerism, position isomerism, functional group isomerism, metamerism and ring chain isomerism. So let's see them in brief. Okay, for chain isomerism the compound should have same molecular formula, and it should have same functional group or same multiple bond, but the different parent carbon chain or different side chain. Okay, This is the only difference. The parent carbon chain should be different, or number of carbon atom present in the parent carbon chain should be different, or you can say that different side chain or substituent or different branches, you can say that. Okay. So for position isomerism, the compound should contain same molecular formula, same parent carbon chain, same functional group or same multiple bond, same side chain also, or you can say that substituents or branch, but there is only difference in their position. Okay. The position isomerism is basically due to the difference in the position of functional group or multiple bond or substituent. Okay. But it should contain same molecular formula, same PCC, same functional group, same multiple bond and same side chain also. Okay. The only difference is in their position. Okay. So if a compound shows both chain isomerism and position isomerism, then the priority goes to the chain isomerism. Okay. So it is the functional group isomerism. So in case of functional group isomerism, the compound should contain same molecular formula. So different functional group or different multiple bond it can have. Okay. So here it is the example of different functional group. Alcohol and ether are two functional groups of each other. Similarly, aldehyde, ketone, acid, ester, cyanide, isocyanide, Na2O, NO. Similarly, 1 degree, 2 degree, 3 degree amine, 1 degree, 2 degree, 3 degree amide. Similarly, alkyne and alkadiene, these are all the examples of functional group isomerism. For metamerism, the compound should have same molecular formula, but there should be different arrangement of atoms around the polyvalent functional group. This is the PVFG, that means polyvalent functional group, or it is also known as the bridging functional group. Okay. But one thing you have to note that in case of metamerism, the compound should contain same functional group. Okay. So here it is the some example of polyvalent functional group. These are ether, thioether, C double bond O C. Here these are the all examples of polyvalent functional group. Okay. The groups on the arrangement of the atoms or group in these two positions should be different. Okay. So here it is the ring chain isomerism. For compounds to show ring chain isomerism, they should have same molecular formula, but different mode of linking of carbon atoms. Okay. So it can be either open chain or closed chain. Okay. So difference is lies between open chain and closed chain. So one thing you have to note that ring chain isomers are also the functional group isomers, but priority goes to ring chain isomers. Here is the another point. For ring chain isomerism, the degree of unsaturation of the compound should be greater than or equal to 1. So this was the brief or summary of the different structural isomerism. So thank you for watching this video.